Good morning, everyone that's joined us today. Hi, I'm Jim Saprinsky here with our speaker, Johannes Rahlf, and our guest host, Taiwo, and a few other of us in the background. We're going to get started here in just a few more minutes and let a few other people come in. I see many of you are arriving. We had over 100 registrations for this, so I know you're excited. We hope everyone's doing well. Staying warm if you're in a cold place. Staying cool if you're in a warm place. I see people are joining us. Folks, if you're joining us, we will be getting started here in about another minute or so, just to make sure we have everyone signed in before we jump into this. Exciting presentation with Johannes. I think it's appropriate we're having a session on trees in the middle of the holiday season. We didn't plan it this way, but it just worked out. Okay, Taiwo, why don't you take us away?
Okay. Yeah, good morning, everyone. We want to say thank you for joining today's TechCast. And today we have Johannes Rahlf, a research scientist that will be walking us through advancing forestry through AI-driven insight from a sensor data. This is a very unique TechCast today, and I want you to listen and also gain insight from this as well. Next slide, please. Again, we also want to remind you that we have enormous amount of collateral with videos and slides. And as we get them, they are added almost immediately after the presentation. You can watch them on YouTube as well. So we have the TechCast for today as well, and also for January upcoming ones. So we also encourage you to go to our website to submit your abstract, www.andouc.org/techcast. So you can submit your innovative abstract as well and for review. Next slide. Again, there are lots of ways to connect with us through the website, like I mentioned earlier on, and also from the YouTube as well, LinkedIn as well, and also the social media as well. The best way to connect if you have urgent question is through the Slack, which we will respond to immediately. So if you have questions to ask, you can also reach out to us from anywhere. Next slide. So I hope you can see this. So this is the save the date, the 2026 summit that is coming up. We are actively waiting. We can't wait to see you guys to come for this conference. So the conference is happening next year, April 14 to 16. Registration is still open. And the earlier, the better you register as well. Next slide. Okay, before I hand over to Johannes, just some housekeeping. So if you have questions, go through the Q&A and submit your question, we would answer. Thank you, everyone, once again. Johannes, over to you.
Thank you, Taiwo. Yeah, thank you for the introduction. My name is Johannes Rahlf. I'm a research scientist at Nibio. Nibio is a state research institute dealing with forestry, land use, natural resources in Norway. Yes, and I'm presenting on this advancing forestry through AI-driven insights from sensor data. And I'm a forest scientist. I have a PhD in forest inventory and remote sensing. And yeah, I want to show you what we are doing actually with AI and sensor data in Oracle. So why does forestry need a digital revolution? So forests cover about 30% of the global land area. So we need forests because they provide a series of services to us actually. When you look at this picture, so this is this forest provides first a habitat to many plants and animals and fungi. So it's all biodiversity hotspots are actually in forests. Again, to that slide, sorry. As also, when you look at that slide, who wouldn't like to take a walk in that forest? So this is another ecosystem service. We use forests for recreation. We like to walk, we like to run and cycle in forests. And then as well, forests do give us protection from erosion. They protect the soil. They give us clean drinking water. Many people are dependent on that service from forest. And of course, last but not least, forests do provide us a very, very important resource, which is timber, because we like to live in houses that are made from timber. Timber is a sustainable material. It's strong, it's flexible, it's resistant, and it's climate friendly. So that's also one service that we use from forest. But forests are also threatened. We have climate change that leads to droughts. We have insect attacks, large scale on forests, and of course forest fires. Every year we get news on new forest fires or larger areas that burn down. Yeah, and this is the background we do forest management on. This is the background for all forestry activity. We want to get wood out of the forest, and we need wood. And therefore, we need forest management. And forest management can also help us then to mitigate and handle some of the threats to the forests while fostering all the ecosystem services. But management gets more and more complex as well. That means we need better information. We need better insights from this information to make better decisions. And that's why we need a digital revolution in forestry, because forestry also lags a bit behind. It's a very challenging environment, forests. So there's a lot of work to be done. And that's what we deal with in Smart Forest. This is a research project I'm mainly working in. It's a center for research-driven innovation, where partners from the public administration, the forest industry, and research institutes, one of them is Nibio. We are working together for a digital transformation of the forest sector through implementation of enabling technologies. And on the left-hand side, you have these buzzwords from actually that came up when the project was started 5 years ago. It's a very long project. It's 8 years. So, but 5 years ago, we came up with these words or these enabling technologies: drones, remote sensing, machine data, blockchain technology, robotics, and IoT, and sensors as well. And they all work together, or they have to be bound together through big data back then and AI now to create innovation. Yeah, and here I want to present how we deal with sensors and sensor data, because we already have quite a lot of sensors in the forest, and we plan on putting even more sensors out in the forest. So first of all, on forest machines, there are many sensors. There are these big, high-tech machines. They have quite a range of sensors in them. Then we have cars on the forest roads already that have sensors more and more. And then, of course, we get data from helicopters and planes and satellites that we already use. And then also drones that get more and more common in forestry. So it's often that forest managers have a drone and to get a better overview over their forest, because when you're down there under the trees, it's hard to actually see what's going on. So drones are actually a tool in forestry nowadays. And we want to support that. And then there are also sensors in sawmills where we can get information on the timber that is cut. Yes, and to get all this information together and make better and create insights for better decision, we came up with this system, which is called, or with this platform, which is called ForestSens. It's a platform for generating insights for forest sensor data. So we have a central platform, and the users are able to send data there, and the data is then transformed into insights, and then that the user can then use again to make better decisions, because that's what we want. Yes, and then there are some concepts we came up with that we think ForestSens should have, or that ForestSens actually has. So it should give better information across the value chain through sensor and AI integration. Then it should strengthen existing support systems with this better information. Then the data ownership should be retained by the user. We want ease of use for all users. And finally, we want to have it modular and versatile for simple updates to our to the system, and also to be versatile in input and output, what the user can actually put in and what they get out. Yeah, and now I want to go even a bit further into the details. So this is the framework. So we have a central platform that is located in the Oracle Cloud infrastructure in OCI, with a central database, with APEX, and other components like the data science service, which you use heavily, and then object storage to store data, and we interface to the users through first APEX and through other APIs. So the users send sensor data to the platform and gets insights out. But we also have sensor platforms that can actively send data directly into our system, so that the user can continuously get insights when these platforms send data. And then, of course, a big part of this whole system is us at Nibio, for example, the researchers. We can provide models and processes into this platform that can be used to transform the data from information to insights. And here we use models and processes that are actually validated and peer reviewed. So the user actually knows what they can expect from the insights they get out, or from this transformed information. Yeah, and now I want to go through some examples of what actually the user can do, what kind of data they can process here in ForestSens. So what we do, we have grouped all these algorithms to transform data into senses, or senses is a number of algorithms with same input data or same transformation algorithms. So we have PlantSens that deals with planting, PointSens that deals with all kind of point cloud data, HarvestSens for a platform for the harvester, MillSens for sensors that are based in the sawmill, DroneSens for data from drone imagery, and RoadSens for data from cars. But these can easily be This list can easily be expanded, but this is the things we have at the moment, either already implemented or in the pipeline to be implemented. And yes, and I will start with DroneSens, which is the most advanced sense we have at the moment that deals with imagery from drones. Here you see a drone flying over Norwegian forests, very spectacular. So this drone takes images from top down, vertically down onto the ground or onto the forest. And in general, how the whole pipeline works in DroneSens is the user, after he's flown his area and took these top-down imagery of the forest, they then upload their imagery to ForestSens. They go into the APEX application, upload it, and then yeah, actually the image before. Sorry, I go back once. You actually need two drones to do this image. So we need one drone to take the image as well. So you need two very well-trained drone pilots here. So the raw drone imagery is uploaded to ForestSens, then it's transformed through photogrammetry into an orthophoto, which is a spatial image or image with spatial information that you can put into a geographical information system. And then we take this image and transform it with an AI model into actionable spatial information by classification or object detection, for example. And how does it work in OCI? So object storage stores these imagery. Then we have a data science job that is running Open Drone Maps, open source photogrammetry tool that transforms it to an orthophoto that gets saved in the object storage, and then another data science job for the AI model. And in the end, the information is stored in the database in a spatial format. An example would be here, it's very much used, is like a post-harvest assessment, which is actually two algorithms. So a forest manager takes their drone and flies this clear cut, and then they upload the images to ForestSens, and then first what they do is they get out the wheel ruts, so the damage to the forest floor, because we want to minimize that as much as possible. And you see here in this area, it looks quite red, but you see the machine operator, they were driving actually on these tracks, on these predefined tracks. So it's actually quite nice area, nicely done. And then the forest manager can also ask for the remaining trees to be detected, and this is also shown. So this is a tool that could well be used for certification or for documentation of such a harvest. And would be, for example, important for certification that your timber comes from a well-managed site. Then we have tree health detection implemented. So forest manager or forest owner flies the drone because there was a snow breakage. There was too much snow on the trees, so some tops broke, but the forest manager doesn't know where they are, these trees. But they take their drone, fly the area, and then put it in ForestSens and ask tree health detection, and then they get these actually spatial indication, where are actually my trees that have broken tops, and then they can use that information to do a salvaging cut, and then they know exactly where to send their harvester to do this, and don't miss any major spots. Yes. Again, the framework, and here I want to show how the spatial part of ForestSens actually works. So We have the database that stores the spatial information as points and polygons. We also want to put rasters there. We're not there yet. We've started to implement that, but it's not there yet. So far, rasters are stored in object storage, but that's the plan for the future. Also put everything in the database, and then use Oracle Spatial Studio to actually visualize the data, or that users can actually visualize the data through APEX with Oracle Spatial Studio. And also what we do is we publish all the spatial information through GeoServer as WMF or as Geo Web Services in the end. And this is also very much used. Algorithm is just storm damage detection after windstorms. There might be trees, fallen trees. So we need to assess where are these trees. Again, we take a drone, fly the area, and then put it in there, and we get an indication of, or we can evaluate the damage. This is used by large Norwegian insurance companies nowadays in their pipeline to actually evaluate damages to forests of their members. And here I want to show how we run actually these AI models, because we use data science services or the data science service in OCI. So everything is organized in data science jobs. That's very convenient for us. We can just use these, we can develop everything locally and then just package everything up, either as a script or in a Docker, and then load it into the registry in OCI and publish a data science job that we can actually just use for to transform the data. So and in these data science jobs, I mean, they're serverless, so we don't have any costs. Well, they're just stored there only when they're run, and we can actually customize them as we need them. Or because different algorithms, they have different computing needs, so we can have large or small machines just as we need it for each job. And this is a very, not only for forestry, I think in general, anything with data transformation, this can be used but perfectly for any kind of research. What we run on these data science jobs is Open Drone Maps, a photogrammetry tool, and the machine learning and AI libraries. Yes, then I want to come to our most advanced sense, that is PointSens, where I think we are like top of the line, or where we have top of line research. What the goal is here, we have point clouds that are generated by laser scanning, either from a backpack or a plane. And I mean, this is our raw point data. It's actually information is X, Y, Z for each point. That's all there is in the raw data. But then we can take AI models to actually segment single trees and to segment parts of the trees. And in the end, where we want to go is to a single tree information, that we can take parts of the point cloud out, a single tree, and then visualize it and predict its attributes, like here on the right-hand side. And there we have three very advanced algorithms, that is segment any tree for INET and Forest Former 3D, that do actually that. They're segmenting the trees into, or the point clouds into vegetation and stems and leaves and branches, and then also segment individual trees. So, and this is used by many people all over the world in ForestSens. We have users from the US, from Australia, from Canada, from Europe, that run their data through ForestSens. Yes, and further with our framework, here I want to show APEX, because APEX is actually that's the component that orchestrates everything. APEX and the database Actually, these senses are stored in the database, and APEX then orchestrates the whole pipeline. So it does the process management, and of course, what's also very nice with APEX is I'm a forest researcher. I have no education in software development or cloud architecture. When I started with this project, I had no idea about cloud or anything. But with APEX, I was actually able to program this. Of course, you need some programming, of course, but even for me, it was manageable. And it's also nice for quick deployment, development and deployment, and it's well integrated with all the other components, object storage and data sciences. And of course, has the interface. And you can also take your APEX application and transform it into a progressive web app. And then you can also have it on your phone in the forest and upload data directly from there. Take your drone flight, upload it from the forest to ForestSens, and when you arrive in the office, you might even have your results already there. Yes, and this is how the website looks like. It's quite simple. So the idea is the user shouldn't spend too much time here. They just need to get the main information. But then the data in the end should be consumed through the APIs or through just downloaded from here, but they should actually end up in the user's decision support systems, so that you don't have to look at anything here in the APEX application. But it's very nice for upload and for then just checking in on your processes. And then on the right-hand side is the progressive web app. Yeah, and then another example of a sense. This is RoadSens, developed by my colleague Mustafa. It's a box that actually is able to scan forest roads, any roads, but it's made for forest roads, where you can then, where it's a stereo camera that scans the road and a very good GPS a receiver. So what you get is then a road segment. And this is the intermediate data, but this is then here again, it's the system, the box. You can just plug it on any car. It's actually used by some municipalities already in Norway to actually scan their forest roads. And this would be an example of insights you would get from this data is once the road surface and the profile, because you want to have a very certain profile that is able to actually lead away water, because that's what damages the road for once. And you want to see if there's vegetation on the surface, so that you can cut it, that it's actually that you're able to drive on the road. And then what it also detects is stones and potholes, so you know where to put your maintenance, because potholes is usually, that's the first part where it starts, where roads start to deteriorate. And in forestry, roads are very important because that's actually the only way to get your machine into the forest. So to do forestry, you actually need forest roads. Forest roads is the first thing you have to have in the forest. And you want to maintain them because they're also quite expensive. And the earlier you come, and the better you can distribute your efforts, or the less it costs to maintain these roads. Okay, again, our framework. This time we want to look at these IoT devices, because RoadSens, for example, this was an example for an IoT device. So it's a box. It does do some processing already in the box. So the stereo processing is all done there, and then also some parts of the AI inference is already done in the box, but then it sends some data to the object storage and some data already and some results already to the database. And the database is then also able to send information back. So you can actually steer your IoT devices from ForestSens and use, for example, APEX as a user interface to your IoT devices. Another device that is very simple but very useful is this planting device. It's actually a very simple planting tool that is also used when it's not smart. They use a very, very similar tool that punches a hole in the ground and then you put your little tree in. And here our PlantSens system does exactly the same, but it also takes a GPS coordinate. It records the exact position of the planted tree, and it takes an image of the tree. So in the end, you have some documentation on what you have planted where. So if the forest manager or if the field crew is done with the planting, or even while they're planting, the forest manager or the forest owner can go in and actually look into what is going on. Are the trees planted correctly? And then they can also take this information further and say to the authorities, say, look here, I want to have my subsidies because I did plant the trees, and this is my proof. You can go and look at every single tree. And for the field crews, also here, there is some advantage. They can prove that they have planted trees, and they can also get information where they should plant trees on a handheld device. And with the positioning of the smart planter, they see exactly where they are and where they should plant what kind of tree species. And our last IoT device is HarvestSens, developed by Chongo Horvath, one of my colleagues, which is a sensor platform on a harvester. I mean, these harvesters have already quite a lot of information, but one thing they don't have is, for example, laser scanners. And here we have 2 laser scanners actually mounted on top of the harvester. Very good positioning system as well, and a camera. And from this information, we can then, for example, there's one example here, track the harvester head. This is a point cloud just projected onto into 2D, and then we run an object detection model that detects the harvester head. And this is quite useful to actually, because from that information we can then calculate the exact position of the harvester head when it cuts the tree. And from that we can actually get the information where the tree was cut very accurately.
So, Johannes, hi, this is Jim. I just
Hi.
had a question.
Yes, please.
So that's actually the 2 sensors on top of the harvester, right? Looking at where the harvester head is as it's cutting the trees. Because
Yes,
that's
I mean,
awesome.
yeah, exactly. The laser point here. This is one of the sensors, as far as I know.
No. Okay.
And there, so they're sitting on top of the here they are. Here, these are the 2. There and
Yes,
there, 2
yes.
laser scanners, and these are the GPSs or GPS antennas that also
Wow.
allow to know in which direction the harvester is pointing. And from these laser scanners, this is one example. What you can do is the tracking of the harvester head, but you can do what's actually the goal is to create a point cloud, as I showed before, from the whole forest, and then you know where are the trees, where were the trees, and which trees were cut. So this is very, very needed information, and information that we would like to have and that we don't have at the moment.
Yes. By the way, we do have a couple questions, and I know you're getting towards the end of your session, right? I think, but I just wanted to ask, a couple folks were asking if why you use blockchain in if we was there a concern about security or hacking?
No, it's that's a good question. I think in the newest version of our work plan that is coming out next year, the blockchain is not there anymore. Well, I think we had high hopes on blockchain. 5 years ago, there was a hype word. So that was a buzzword everybody had to use. But I think there are some applications where we actually could use blockchain, especially in certification, where you want to show where my tree is coming from, and then add up all this
Gotcha.
information.
Right.
So that would be in one idea
Okay.
how we could use it.
A couple more questions. This is from Raw Campos, by the way. It seems not hard to extend the drone platform for on-the-fly reforestation. Any ideas or any plans for that?
On-the-fly reforestation. You mean,
yeah. I presume, Raul, you could add a little bit more here, but I'm guessing like maybe after a storm or something along those lines. Again, I'm not a forest scientist.
No, but absolutely. I don't know. I mean, in the end, you get an information from the DroneSens platform.
Right.
You have these different algorithms. You can show where are the trees at the moment. We also have one algorithm I didn't show here is a seedling detector. So after planting, you could, a year or two later, you fly your drone and then you see actually where these seedlings you've planted before, how they're doing. Are they still there, or did they die? And then you can go out again and plant these little gaps, put new trees in. Sure.
Right. And one other point, and I think this is a brilliant point. Couldn't you use these videos to promote ecotourism? I've been on some tours where actually we were taken out into the forest and said, "Here, we're gonna help forest or reforest a particular part of the plant," and then you could take any of the ecotourism and reinvest it back into the forest maintenance. Just an idea. It sounds like a really intriguing idea looking at this.
Yeah, totally. I agree. There are so many possibilities we have.
Right. Yeah.
It's just to develop the models, and then feeding
Exactly.
that into the platform is easy. You just need a script or a container, upload it, and then it's there.
Right. Awesome. Please keep going. Sorry for the interrupt, but it was a good time to take a deep breath. Please keep going. This is fascinating.
So yeah, I'm actually coming to the end of my presentation here. So what I'm currently working on while maintaining the platform and developing it, one big part now is our ForestSens SDK, or the API, because we want others to be able to access ForestSens programmatically. You can use ForestSens through the APEX interface. It's very good for testing. It's if you want to test what these algorithms do. But if you have a large amount of data you want to feed into ForestSens, or many different areas, when different areas you want to feed into ForestSens, then it's actually better to do it programmatically. And here we created this ForestSens REST API. Actually also through APEX. So that allows direct communication to the database. So you can all the things you do in the APEX interface, you can do now through the REST API. You can directly load your files through to object storage, upload and download. Security through key-based authentication. And you have standardized output and input. And around this REST API, I wrote a small Python library, ForestSens API, which wraps these REST endpoints into nice functions. So even the researchers from the neighboring university, they're able partners in the project, they're able to use that easily without having to learn how to deal with REST APIs. So they can just use their Python program and just plug in their API library and run their batches through ForestSens. And yeah, especially the upload a direct communication to object storage is it's very stable, and we're able to upload larger data actually through this API. Yes, I'm already coming to the end of my presentation. What I wanted to say is, so this is not only my work. I'm a main developer of this platform. I'm maintaining it due to user support. We are a research institute. This is how it works. But I mean, in the back end, there are so many people who have helped working on this. There are many colleagues here at Nibio that developed algorithms and models, also at NMBU, the Norwegian University of Life Sciences next door. And then there is, of course, a team from Oracle who helped us develop this platform because we came from nothing. So actually, we tried first doing it in Amazon, AWS. But there was no support at all, and then we started. We got in contact with Oracle, and we got a lot of help. And now this is where we are. And now we have this ForestSens API. This is used now by the big insurance company, and one of the biggest insurance companies in Norway on forestry. They run their data through ForestSens. The state forest company, they run their drone imagery through ForestSens. And yeah, this has been a huge success, and wouldn't be able without the help of quite a lot of people. And what I want to say, if you have a drone and a forest maybe, or you know somebody who has a forest and you can fly your drone there, you can try ForestSens. Just go to forestsens.com, register there, and then I have to approve you. Yeah, the platform is not completely open yet. It's mainly for partners in the project, and yeah, and people we let in, but we are not too restrictive. And
nice. I do have another question for you, Johannes. Someone has asked, are there any opportunities for OCI employees? I presume maybe somebody from Oracle, but what do you mean OCI employees? I don't have a name here. To volunteer and maybe assist with data collection.
With data collection? I mean,
yeah.
The idea here, the idea
Oracle
of the
cloud infrastructure, yes. Employees. Go ahead.
Okay. Yeah, I mean, the idea here is that we don't own any data. We just provide the service. This is actually very nice for us. We can put in our models, our processes we develop. Like this is why sorry, I have to go back. Why I put the researchers here on top, because this is and we want our models to be used. Because what usually happens, we do research, we write a good paper, we might publish code, but then nobody uses it because nobody knows how to use the code. I mean, it's also so often so badly written that nobody knows how to run it. But here we can just plug it into ForestSens and then just say, this is the paper, this is the code. And here you can try actually the model. Take your data and try it with your data. And I think that's one reason why we are so successful here.
Right.
So this is not our data. We want other people to use their data.
Right, right. Yeah, by the way, that was from somebody on the Oracle Spatial and Graph team, just in case you were interested who was asking. It's very interesting. I actually was working with a young high school senior who is very interested in developing a similar set of technology for helping subsistence farmers across the world with lower cost drones, right? Not the super expensive ones that are up in that price range, like you were showing, right? Some of those drones are in the tens of thousands of dollars cost. But he said, I certainly can handle the drones. I can do 3D printing and stuff like that with a makers community. But what platform can I use? And now I have an answer for him.
Absolutely. These drones,
That is so cool.
the images I showed, these drones, they were just commercial drones you can buy in any drone shop,
Okay.
I guess. It's
Wow.
mainly DJI drones we used here, but there are also other drones have been used with the platform. The only information we need is we need the image and we need some coordinate, which usually comes with the image when it's acquired by like a commercial drone.
And we actually have a question on that. Martin Voss is asking, what about the drones and other tools to scan the data? Do you, I don't know if he means you specifically, but does Nibio actually sell them?
No, we are a state research institute. We don't sell anything. So we do research for
Okay.
the public. We get paid by the public. So the whole project here is public is funded by a public research grant from the Norwegian Research Council. So what we do is
Wow.
public. I mean, the insides of the platform here is not accessible, but you can of course write me and I will answer you. There is no secret here. Um,
Cool.
and the models that we use there are published. So you can also recreate this platform if you want.
Right.
Um,
Right. Yeah, that is awesome. That is wow, science working
Interesting.
together with government. What a concept.
and industry. I mean, there's
And industry. Yeah.
the largest industry partners in largest forest industry companies in Norway are part of this project. So they're also of course financing it a little bit.
Right. Fantastic. Unbelievable. That is amazing. Can you throw your last slide, your
Yes,
personal last
please.
slide back up there
Yes.
with your contact info so everybody can reach
Yeah.
out to you? Because I think a lot of people are going to be reaching out to you. There we go. Wow. Okay, we have no other open questions, but a lot of engagement from people. Thanks for everybody showing up today. Uh, Johannes, I think we have a couple of last slides, just a little bit of housekeeping here. Um, so I just wanted to remind everyone again, as we're reaching the end of the webinar today, we do have quite a bit of really interesting stuff out here. Obviously, we'll get Johannes' slides out there as soon as he turns them over. We'll have the video out there probably later today or first thing tomorrow morning out on YouTube. And I also wanted to bring to your attention, we have a lot of collateral, as we like to say, out here. We're also now documenting our collateral a little bit better. So it's easier for you to find things inside a particular video. We know these are long form videos, but we have a lot of stuff to show. Also, we have we're continuing sort of a spatial and graph series here. We have another one coming up on January 8th with my colleague Meli Anamale. And actually, she's going to be talking about a customer use case inside the January 8th one, which is about using graph analytics for fraud detection. Fascinating topic. Could I have the next slide, please? One other point, yes, we've been talking up Analytics and Data Summit 2026. Please, if you're thinking about coming, registration is open. We just announced yesterday our keynote speaker, one of our two keynote speakers, possibly might be more than two, but our first keynote speaker was announced. It's a young woman named Susan Early, who has a fascinating background, including advising principals at NASA here in the United States. And she's a lawyer too. And she's going to be talking about artificial intelligence and what it all means. So she's going to be our kickoff keynote as it looks right now. We are going to have a fantastic conference coming up this April. Please check out our page. We are almost done going through all the nearly 200 submissions for this conference. There's some amazing content that we're going to actually have there. And I think that might be our last slide. We have one more, possibly, I think.
Oh yeah.
Perhaps. Some helpful video links here. Please be aware we also, talk a lot about Oracle Analytics Cloud. So we've got the July and September features out there. The Oracle Analytics community, obviously, it's in our name. We have all kinds of excellent videos out here, but also, of course, our colleagues at Oracle have produced some excellent analytics and information out here for you to take a look at. With that, I don't have any other questions. I think we're going to wrap up a few minutes early. But Johannes, I just want to say it's utterly amazing that you said you had no coding experience and you folks have built this all inside Apex. Do you want to speak to that as we wrap up?
Yeah, I mean, of course, yes, we are researchers, we write some scripts for data analysis and stuff, but no proper software development background
Wow.
But we had a lot of help from a team from Oracle and here in Norway that supported us. Thank you very much. I see some are here in the audience.
Yeah. Yes. Yeah.
So
Awesome.
that was great help. And yeah, now we run it without any previous experience.
Amazing. Amazing. Wow. What a shout out for Apex and Spatial and Graph. Amazing. Well, folks, we're going to wrap this up. Have a great rest of your December. Please do check out our January 8th session. As we mentioned, we're kind of on a Spatial and Graph roll here. And have a great holiday season, no matter whether you celebrate or not. Have a great day, folks. Thanks, Johannes.
Thank you.
Bye.